Ok, dobrodošli ljudi, ovo je drugo dešavanje u Beogradu, sada pokušavamo nešto novo, znači imamo izlet na Adi Ciganliji i tu je lep meetup, lep dan, tako da nam je mnogo drago da su svi došli. Imamo 3 prezentacije ovde na ovoj livadi. Prva prezentacija će priča Marko Simic, čovek koji je bitcoiner, ali se bavi veštačkom inteligencijom i radio je u nekim kompanijama po svetu u tom polju, tako da će biti mnogo zanimljivo da čujemo šta čovek ima da nam kaže. I eto, to je to, dobrodošli. Marko, jesi spreman ti? Jesi, odlično.
What do you want to do about questions? Do you want to... Yeah.
We'll ask questions as you talk, yeah.
Fuck. Yeah.
Just pull it a little bit. Yeah.
Minus. Okay, this is... Yeah, so I'll speak in English if that's okay with everybody, because it's just easier for me. Sorry about that.
Me too.
And it's gonna be fairly non-technical presentation, and stop me at any time when you have any questions or you want to ask. And the outline of the presentation is going to be just a brief history of the AI field, how it all started, then what is actually AI, what types of AI do we have. Then we will focus more on neural networks, then talk more about large language models that are all the rage nowadays, and talk more about their capabilities, shortcomings, some risks, and then we're going to try to tie in a little bit of Bitcoin into this AI talk, but we'll see if I'll be successful in that. So history of artificial intelligence. Throughout history, people wanted to make autonomous machines, right? But it kind of all started in 1950s. Alan Turing, famous mathematician, came out with a paper in which he proposed a Turing test, basically a test in which we could determine if the artificial intelligence is on the level of a human. And then in 1956, there was a famous conference at the Dartmouth University, and that was the official start of the artificial intelligence research field. And since then, there has been a lot of development, right? But it was mostly academic and not really that visible to public. One of the major public stunts and successes was actually in 1997 when IBM created Deep Blue system to play chess, and that Deep Blue system beat Garry Kasparov in chess, and that was like a huge thing, right? Everybody was scared from AI at that point, like AI is taking over. But that the blue AI was and is very different than what we have right now in AI, and in a way it's a very simple machine, and it works on a completely different principle than current AI. Then, for example, in 2012, we had a major development and success with neural networks. That was the time when neural networks started working on images. There was like a famous competition called AlexNet, called ImageNet, and the research team employed neural networks to recognize images, basically cats, dogs, cars. And that neural network was vastly more successful than any other system up to date. Like, I think it was like 10 points more than any other system. And since then, neural networks have been a dominant form of AI. in 2013, like 1 year after AlexNet, we had a huge success in applying neural networks to play video games, like Atari video games. Then in 2016, there was also a huge public story where an AI system was successful in beating a world champion in a game Go. And Go is actually much harder and more complex game than chess. And many experts did not believe that the AI system can play Go on the world master level. But AlphaGo was able to do that, and it basically demolished world champion, human world champion. And that system, AlphaGo, works on a different principle than Deep Blue that played chess.
You know, so when Kasparov was playing Deep Blue, he won like the first few times, and then finally Deep Blue won?
Yeah, I'm not sure. I think he did win some match, some game, but I'm not sure in what order and how many. And they played, I think they played twice.
I think he won once or twice, and then
Yeah, something like that.
because
Yeah.
he said he didn't really get beat. There was a few things for that. But in Go, the first time they did it,
Yeah.
beat the player, or
Yeah. Well, the system has been playing undercover for a year, basically, over internet. And they had internal tests in the office. But during the official publicized match with Lee Sedol, that was the first game with Lee Sedol. And AI system won 4-1. Yeah, exactly. There's a documentary about it. Maybe AlphaGo. I don't know. Yeah. Then a year after that, 2017, there was a very unassuming paper called "Attention is All You Need." And at that time, it was like, yeah, cool paper, but whatever. We use it for some things. But actually, that paper is the basis for GPT now, right? And it's very important. In 2020, we had AlphaFold 2, which is a system that some say solved protein folding, which is a major scientific achievement. And then now in 2023, we have GPT-3, GPT-4, we have DALL-E, Midjourney, and basically the whole group of generative AI that you've probably heard about and maybe even using. And during these like 60 years, the whole AI field went through cycles, basically winters, right? There's a lot of hype, we overpromise what we can do with AI, and then it all crashes, right? And you probably even noticed maybe with self-driving cars, right? 5-6 years ago, everybody was talking about self-driving cars. We'll have level 5 AV vehicles on the roads by 2020, but that didn't happen. And you don't hear about AVs anymore. Sorry? That you should not be listening to Tesla's public statements. The most advanced autonomous vehicle systems are Waymo and Cruise that operate in San Francisco and Phoenix, Arizona, and they could be considered as level 4 autonomous vehicles. But what that means is that it can operate without a human in a very restricted area and under certain conditions, no snow, no fog and stuff like that. But whenever the conditions are bad, it can't drive anymore and things like that. But yeah, overpromise and underdeliver. That was always the motto of AI field. And AI is an umbrella term. There's like no one thing that's like AI, right? It stands for artificial intelligence, but it's just an umbrella term that consists of a bunch of mathematical models that rely on linear algebra, on statistics, on probability theory. But broadly, it can be divided in 3 groups, like symbolic AI, connectionist AI, and neurosymbolic AI. So symbolic AI are systems that store knowledge explicitly and operate on that knowledge with rules. So for example, if AI system has to know about this table, it would have tables stored somewhere in its memory explicitly, like your computer, right? And then when it needs to do something with that table object, it has rules how to do it. So symbolic AI is very brittle, and we don't use it that much. Neural networks are an example of connectionist AI, and the difference is that there is no explicit knowledge in neural networks. When you open a neural network, you only see a bunch of numbers, but there is no representation of a table, of a laptop, of a person, or anything like that. So all knowledge and all rules are stored in the connections between the neurons in that neural network. And then finally, the third type of AI is neurosymbolic AI, which is a combination of symbolic models and neural networks. So what are neural networks? They're loosely inspired by human brain, and really very loosely. They do not resemble anything to human brain. So brains have around 86 billion neurons, and each of those neurons is connected to up to 10,000 other neurons. So that would make like 100 trillion connections, synapses in the brain, which is not how artificial neural networks work. So what are the artificial neural networks? There are different types of networks, but for example, MLP, which stands for multi-layer perceptron, which would be the most simple one. There are like convolutional neural networks, recurrent neural networks, and now we have something we call transformers. But what is a multi-layer perceptron? The most basic neural network. It consists of several layers of nodes, more or less, right? You have an input node, input layer with, for example, 5 nodes, and you have an output layer with, for example, 2 nodes, and in between you have several layers with maybe 10 nodes each. And every node in a layer is connected to all the nodes in the previous layer. So node in the layer 2 is connected to all 5 nodes in the layer 1, right? And what happens is you put data on the input size, and you just multiply weights with that input, and you get the output of the layer, and you just propagate like that. And mathematically, that is just matrix multiplication together with some nonlinear function. And that's pretty much it. It's a super simple mathematical concept. Literally, matrix multiplication plus nonlinearity. You put some input, for example, table, right? It has 5 words, right? So each word would go to one input node and then propagate to the output. But what is interesting about neural networks is that they're not fixed. We train them because when you create a neural network, it doesn't know anything. It's completely random. All the weights in the neural network are initiated by random. So when you put an image of a cat, for example, on the input, and you want to know if it's a cat or a dog, at the beginning, neural network outputs just a random cat or a dog. But what we do is we train neural networks. We have a lot of data, a lot of examples of images of cats and dogs or whatever we want to classify, for example. And then when network predicts good, if we put an image of a cat and it predicts a cat, we say, okay, this is good, keep it up. But if it says, oh, this is a dog, we say, okay, this is bad, this is actually a cat, change your weights a little bit. And then weights in the neural network are adjusted, and through that feedback loop, we basically train the neural network until we're satisfied with the accuracy of the model.
Is it true they're using CAPTCHA as like a training model? You know those image prove your...
Oh yeah, that is true. Whenever you solve a CAPTCHA, one of those,
They're
yeah.
feeding a neural network, right?
No, so you're basically labeling the data set.
Or labeling.
Yeah, you're labeling the data set that will later on be used for a neural network training. That is true. And this method of training neural networks is called supervised training, but there are different methods like unsupervised, self-supervised, and reinforcement learning. But they're all kind of different variations of the same thing, like input and then feedback to change your weights. And yeah, nowadays what we have is the hype around generative AI, right? You hear about GPT, about large language models, about models for text to image like DALL-E, Midjourney, and Stable Diffusion. And they're all just variants of neural network trained in one of these ways. And yeah, let's look at the large language models, because I think they're probably the most interesting right now, because we can use them for everything, and not everything, but like for text related things, and many people are kind of worried about the implications of this technology. So large language models are based on that research paper that I mentioned, Attention is All You Need. And the key architecture part in that neural network is an attention module. What that means is that neural network can selectively attend to different parts of its input. So if you ask a neural network, in what city is the Eiffel Tower located, this transformer network with attention mechanism can realize that, oh, I need to focus on Eiffel Tower and a country, and based on that it will know how to answer your question. But what it does, what these large language models do, is they basically predict next word. They're smart keyboard on steroids, and they're trained in a way that they just literally predict a next word. So for example, if the whole sentence is my name is Marko, you would, during the training process when the network is learning, you would input my name is, and network has to fill in the last word, and it has to guess that it should be Marko, right? And that's all these networks do, predict one next word. But they're trained on terabytes of data, and it's basically a whole internet, more or less, all the academic books, novels, and things like that, Reddit, for better or worse. So they've seen a lot of human text and human knowledge. So even though the system is simple, the final results are very sophisticated and amazing. The GPT-3 network, the previous generation, for example, it had 175 billion parameters, and it was trained on thousands of GPUs for a month of time, right? So it's not something that me or most likely any of you can just train in their basement or a house. So those are huge models that take a lot of money and time and effort to train and deploy. It's a very non-trivial challenge to do it. And that's why when you interact with GPT-4, it's kind of sometimes slow, right? Because it takes a lot of compute to produce the results. But what can we do with it, right? So these large language models basically unlocked human language for machines, and they can be a control system, a user interface for everything that we interact through text, be it like a chat, controlling other computers, writing novels for us. All that is now possible with these large language models. And for example, a lot of developers are using them to help them in coding. and probably many of you are already using it in VS Code or in some other IDE. Microsoft is pushing hard to integrate this large language models into Windows. So I assume that the next version of Windows will have it embedded in the operating system itself, and the AI will have access to your documents, your programs, and it will be your co-pilot. You will be able to ask it to do stuff for you, basically your personal assistant. Something akin to an assistant in that movie Her, if you watch that movie. Basically that. Everybody will have that on their PC if you use Windows. And I hope that Mac will have their own version of that. A lot of businesses are now trying to do like better business intelligence. Basically, if you operate a huge business, you have a lot of documentation, there's a lot of data, and now you have AI systems that can understand all your documents, and you can just talk with your AI and get like all the information you need. It can synthesize and summarize the documents you have. It can extract deadlines and things like that. If you use Notion, for example, you already have AI there. It helps you with writing. It can compose emails, fix your spelling. So it's very powerful, right? And then the other type of generative AI that we have right now that also kind of relies on these language models, at least to some extent, is text to image, text to video, and text to music, like DALL-E, right? You say, okay, I want to, I don't know, dog on this table, and it will create an image of a dog on a table. So these systems will just get better and better, and they will become a part of our daily life, and we will forget about them. Basically, we'll just interact with our computers like it's a normal thing. But
can I ask you now? So Midjourney, ChatGPT is all free. But are they using currently like the interaction with ChatGPT, each of the services to train back somehow the preference of the human?
yeah, so I'm not
modifying your account and your history so they know what you like.
Yeah, so there was a the question was if these companies like OpenAI and Microsoft are using our own data to train these models, and they are. And there is actually an issue in Europe right now because GDPR and things like that. They want to ban GPT from EU because they're not handling the data properly. And OpenAI recently changed their training policy, so you can opt out. You can say, okay, I don't want my data to be used to train next model, right? But if you don't opt out, I think the data is being used to train the model.
I know they store the data, but for the image stuff, like your only option is like upscale and something.
Yeah, so for the image stuff, I'm not sure. They're definitely storing the data, but I'm not sure if they're using that data later on for the training. That I don't know. I would need to look into like.
ChatGPT is more straightforward.
Yeah, ChatGPT has. They definitely use that data, and many companies banned GPT usage for their employees. Right? They said, okay, you can't use GPT for anything company related because you might give up some secrets and stuff like that, right? And that will be also a big business and an opportunity to create customized models and private models for these businesses, right? So if you're a big pharma business, you don't want to use GPT, but you want to have your own private model that is confidential, that will not leak data. So many companies will jump to that opportunity and.
Like generating the stuff, the computing power is like insane, right? But
Yes.
Storing the entire model.
So.
Do you know the size?
So I think that, for example, 175 billion parameter model would take around 200 gigabytes of GPU RAM, and that's just for the inference. That's just not doing training. That's just inference, the forward pass. When you ask it, it answers. But when you train the model, it requires way more than that. I mean, even 200 gigabytes of GPU RAM is huge, right? But for train.
Storage. So if you once you train the model now and once you have ChatGPT at home, okay, so I need 200 gigabytes of RAM.
Yeah,
GPU.
pretty much.
What about storage?
Well, that's so the network would take 200 gigabytes, like on your hard drive, but then you need to load it on the GPU. The good thing is that the progress in AI research is quite fast. So we're coming up with new methods to make networks smaller, to make them more performant, so you can run them on a single GPU like this one, right? Those models are still not as powerful as GPT-4, but they're getting good. Now, so the shortcomings of these models, although they're very good, they're excellent, they have a bunch of issues. And the biggest probably is the tendency to hallucinate, which means that sometimes it just outputs things that are not correct. It will just generate some text and it will sound plausible and believable, but it will be complete nonsense. And that's a very dangerous thing. And it's an active area of research to figure out how to fix it. The reason why they do hallucinate is because they don't have human reasoning capabilities. Again, it's just a smart keyboard on steroids. It's just next word prediction. But yeah, there's a lot of research ongoing trying to fix the hallucination issue. Then another issue is issue of bias, because network knows only what it learned from data. And if our data was bad or was biased in some way, then our models will be biased. So there is a lot of care necessary to clean the data, to prepare it to be good for training. Third issue that we have with these models is interpretability, and not just these models, but any neural network more or less, because there is no rules and knowledge explicitly stored in neural networks. Everything is stored in those weights, in those connections. There is nothing that we understand about them. We know how they work on a mathematical level, but we do not know why they produce the exact results they produce, right? When we look at a network, we just see a bunch of numbers. We don't see something that represents a table or a laptop or anything like that. And in general, it's not a big issue, but if you want to use AI in safety critical applications, like autonomous vehicles, aircrafts, military and stuff like that, and medicine, you want to know why your model is telling you what it is telling you, right? But right now, we don't have that capability. Another issue is scalability. As we mentioned, the current models, large language models, are just giant, and it's not feasible to train them or even run them easily on your desktop PC. So it takes a lot of money, it takes a lot of energy to train and run these models. And then on a more like philosophical level, these there's an argument about this, but I think that the dominant opinion is that these current models, large language models, don't have anything that is similar to human understanding or reasoning. Because again, they've seen a lot of data, they've built the statistical model of your data, but they cannot reason about it. They don't have human understanding of what a table is, what a human is, what a life is. So they can't reason as humans do, and that's an issue. There are ways to the AI ethics and AI alignment is a very hot field of research right now, but there is no such thing as AI morality as of now. But yeah, we will talk about that actually right after this. We can get into that. So what are the risks of this AI technology? Because you've certainly seen in news that everybody's talking about it. Some people are calling doom and gloom and end of humanity, right? So why is that? Obviously GPT-4 and probably 5 and 6 will not end humanity. But the whole argument is sound to some extent. So the existential risk of AI comes from two hypotheses, let's put it like that. One is called orthogonality and the other one is called convergence. So what do these two hypotheses say? So orthogonality says that no matter how smart the system is, that is orthogonal to its objectives and morals. So you can be the smartest person in the world, but you can be completely immoral and a sadistic person. And then convergence hypothesis states that no matter what your final goal is, for example, make barbecue or learn computational biology, I don't know, as you are working to finish and achieve your terminal goal, final goal, you will develop instrumental goals that are beneficial for achieving the final goal. And more specifically, 3 instrumental goals that are important and beneficial in probably every situation are self-preservation, power seeking, and self-improvement. Because whatever you want to do, you will achieve that if you're smarter, healthy, and you have more power, right? And so now when you have these two hypotheses, that you can be smart but also a jerk, and also that while doing some task you will have sub-goals, and you have an AI system that's vastly more powerful than a human, you get in a situation that, yeah, maybe that AI system will not care about humans. And the analogy is, for example, when humans make highways. Highways are great for humans, right? And we don't want to harm animals or insects or anything like that. We are not sadists, right? But we still disrupt the environment. We plow the earth, we clear the ground, so we probably kill a lot of animals and a lot of insects, right? Just to build our highway. In the same way, AI could do the same to us. They don't necessarily want to harm us, but yeah, they just have some objective and they'll do stuff to achieve it. If it harms us, then yeah, it's a collateral damage, right? But that is still like a sci-fi concept, I would say, and we are still not close to it, although many people will disagree with that. What is closer to us and what's happening right now is just using these large language models and image models for illegal and nefarious purposes. So you can create fake images, fake videos, you can clone voices of people and misrepresent them, you can scam people. So there's a lot of real danger in these models. However, the existential risk is still not one of them. And finally, the intersection of AI and Bitcoin. Yeah, we were all waiting for this part. So different AI models have been used for things like fraud detection and market analysis. I'm sure that chain analysis uses some machine learning and AI to analyze your transactions and report you to FBI, whatever. And trading houses are using machine learning and AI for trading. So those are all applications that have existed for a while right now. Maybe additional applications could be something around mining pool optimization. Not really an expert in mining pools, but I can see maybe an application in which AI can be used to distribute work better, for example, or maybe using AI and machine learning to optimize the ASICs for mining or energy usage, things like that. I don't see an immediate use case for these large language models in the Bitcoin ecosystem, except for like chatbots and stuff like that in like wallets or something, right? On the other hand, Bitcoin can be money for AI, because AI can't make a bank account, but it probably can buy non-KYC Bitcoin, most likely, right? So that's a good or a bad thing, I don't know. But maybe one day we'll have AI buying services from humans with Bitcoin. Then another idea that actually Michael Saylor is talking about recently is that we can use Bitcoin to kind of verify and authenticate humans and add a barrier to entry for bots. Because if you're on Twitter and you want to deploy 1,000 bots, right? If you want to verify them on the chain, that will cost you a lot of money. So it's cost prohibitive. While if you're a human, you just verify yourself once and you can do that. So it's fine, right? And then...
It can be used by government.
Sorry?
It can be used by government to find out who is behind the...
Yeah, yeah. Maybe AI will find out who is Satoshi, maybe. Or maybe Satoshi is AI, who knows? And the final idea is something that I heard from Peter Thiel several years ago, where he claims that basically AI is centralizing power, because whoever holds AI centralizes power in their hands for surveillance, for control, for monitoring, while Bitcoin is actually on the opposite spectrum. It's a democracy, it's giving power to the people, right? So in that way, AI and Bitcoin are polar opposites, which is something to think about. And yeah, that's the end of my presentation. So if you have some questions.
I have one.
Yeah.
There is a way to AI UX.
Okay, so the question was, can we use AI to improve UX for Bitcoin? Immediate answer would be some chatbots, right? But that's kind of not exciting. Developers will use AI when they code, but I don't know how would you use it to improve UX?
I mean, there's something you mentioned. This is what I heard about AI for wallets, or having like labeling transactions functions, or routing UTXOs in some way over. I don't know. It wouldn't be like generative AI. It would be like a machine.
Yeah, machine learning system.
I'm not sure if that's possible, though, for AI to be able to recognize the pattern to which the transaction is that, okay, we'll manually label that I've sent Marko. I know that it's Marko, and then I'm going to label it.
Yeah, stuff like that.
Yeah, I think that's the biggest use.
So
AI might be able to...
So I think that's already being done by companies like Chainalysis, right? They definitely use machine learning models to track transactions. And you could probably, as you said, like use machine learning to learn some statistical regularities in transactions, and then maybe label them or group them for like lower fees and stuff like that.
I mean, it's a little bit. The chain analysis doesn't have my permission, right? It just uses publicly available data. But I have it built into my own wallet. I'm giving it extra knowledge. I'm giving the efficient,
Like personal.
and perhaps, yeah, you know, perhaps like allowing them to,
And
perhaps it asks me a question, like, click here, okay,
but what do you want? What do you hope to achieve with that AI? To lower your fees or to just
no,
make?
just get some management, for instance.
Hmm.
It's so much easier to do.
For privacy as well.
Yeah,
Maybe
privacy.
if I keep sending feed, I don't want him to know my other users. I can help.
Yeah, probably machine learning can be used for some of those problems. I'm not an expert in that.
It's not
So,
gonna help, well, maybe even with fees, yeah, like track over time. It's a probability that the fee will drop over.
um,
Anyway, things like this, with these type of UX stuff.
it can be used to create a better UI. Again, if you are trying to deploy your wallets to a fairly low-tech country with people that don't have a lot of experience, right, with technology, so you can have like nice onboarding with like text and voice and like maybe even human-generated avatars, right, to onboard the users, explain how to use that stuff, and be like always present for them to help them out when they can't make the transaction. So stuff like that, especially for older people, right? If they're not that proficient with mobile phones or technology.
Yeah, one feedback that these companies give is that they struggle a lot. Their support struggles a lot supporting all these people.
Yeah.
They have money, they buy Bitcoin, and they have no idea how to spread it.
Yes. So large language models can definitely help with that because they can speak, right? And they understand. They can be a layer in between, and they can onboard and help users. Yeah, that's definitely possible. There are ways in those constrained applications. There are ways to mitigate that problem, so it's easier to deploy them in a closed environment like that, because you can assume that chatbot will not need to talk about like some like drugs or medical interventions or anything like that, right? Yeah.
That's a very limited space. Like it's a closed context.
Yeah.
It's like you ask me something about a library or something, and it has access to documentation. It tells you it writes things, but then when it doesn't know what thing it explains it just makes stuff.
Yeah. Right.
Use this function with these arguments, and it does this thing, and then it's like that doesn't exist, and then it's like, oh yeah, I'm sorry, I apologize. It doesn't actually exist.
Yeah. Exactly. So right now, whenever you use it, you have to be very aware of that problem and double check what it outputs, which is kind of dangerous because if you're not already an expert or knowledgeable in that field, you don't know if it's true or not, right? So it just
Once I told it to create a table, so it said that I cannot create a table, and it was doing it for so long.
yeah. So, but we will solve all those problems at some point. So these are just growing pains. Yeah.
Will AI overtake the world?
So the question is, will AI overtake the world? Possibly at some point in the future, but in the meantime, automation is definitely coming. We are trying to automate factories, warehouses, logistics centers. Now we can automate even white-collar jobs. But the thing is, in most cases, AI is not automating a full job. What it is automating is certain tasks. So humans are still necessary to be in the loop. Yeah.
I have one more sub-question.
Yeah.
Sorry. Let's say that AI gets implemented into the healthcare system.
Yeah.
And it starts managing the files of patients. Is it possible at some point AI decides to be a bad guy and just mix prescriptions?
So the question is, what bad things can happen if we integrate AI into our healthcare system? Many bad things can happen, right? That's why the field of AI alignment and is very important. We need to put safeguards, and we have to be very careful how we implement these systems. We cannot just give them access to our like bank accounts, to our medical records, and just let them loose and do whatever, right? There's a lot of testing that has to be done, a lot of safety systems, but it's all doable. Yeah.
Yeah, very different. Like, you know those 3 rules, I think that's one of some of the 3 rules of robotics.
Yeah.
Like, exactly.
So, yes, so Isaac Asimov, the famous sci-fi writer, has like 3 rules of robotics that are supposed to like guard humans from AI and robots. But the thing is, in every one of his novels, those rules actually break. So they're not good rules. That's not how you're gonna fix the things. So it will take more than that. Cool. Thank you.